Hello, wonderful people. So we are going to be talking about dilations. Finally, we get to talk about this amazing new transformation that it's been there, but we haven't really discussed. And so what is it, right? So when we talk about dilations, two things happen, right? We have a segment AB, and we want to dilate it. But how much do you dilate it by? Well, that how much piece is called a scale factor, okay? And it is right here, a scale factor of K. So any number, really. And when you multiply, right, it's a factor that you multiply by. So I'll multiply this segment by a scale factor, call it K, and that produces A prime, B prime. And notice that A prime, B prime is bigger. But it doesn't have to be bigger. It can be smaller as well, depending on the scale factor. Okay? So the first thing that we know is this piece here. When you multiply your original, your pre-image, by a scale factor, you get your image. Great. Okay. Well, the next thing is that, well, look at these two lines. They are parallel. So when you have a dilation, you always produce parallel lines. Does that remind you of another transformation that we've done that produces parallel lines? I hope so. So here is the two things that we know about dilations, okay? Here are the two, and we're going to talk about one more. Well, how do you do a dilation when you have a point? Well, that's simple. For any point x, y, all you have to do is take your scale factor k and multiply x and y, just like this. Okay? So let's look at an example. Here is our point, our pre-image. Here's our scale factor. This is k. And we want to find the image, okay? But first, we have to use a reflection across the line y equals x. Now remember what happens for our rule y equals x. Recall. Just in case you forgot, okay, this is our reflection rule. So for the point, for our point here, negative 4, 10, this is going to become 10, negative 4, okay? That's our point. Now, what do I have to do? Well, now I have to take our scale factor, k. So now I'm going to take 3 halves and actually multiply it by 10 comma negative 4. And so what do I get? Right? So 3 halves times 10. You got to think about doing that, right? So remember, this 10 here is over 1. So 3 times 10 is 30 over 2, comma, same thing. This is a 1 over here. 3 times negative 4 is negative 12 over 2. This is our point, and let's reduce those 2 points. 30 over 2 is 15, comma, 12 over 2 is negative 6. This is our image. That is our image. Hey, is that point somewhere here? Yes, it is. It is number 2. Yay, yay, yay. Okay, awesome. Let's look at another example now. Here is a line whose equation is given, and we need to dilate it with center origin. Now recall that the origin is 0, 0, people. Okay, that is our center, because we need a center every time we do a dilation. And here is our scale factor. How big do we want it? So is this line getting bigger, smaller? What's happening, right? So notice if we have a scale factor that's a less than 1, the image is going to be smaller. And if our scale factor is greater than 1, then the image gets bigger. You should probably write that down. Let's look at this line. Well, this line is in standard form, and I can't really tell much from it. So this is in standard form. And we need to turn it into one of the forms that we are comfortable with, which is y equals mx plus b. So let's do that. All right, so here are a few things that we know here. Let's see. Well, I know that my y-intercept is 4, some positive number, and I know that my slope is negative, so it's going down, right? So I can actually make a sketch of this graph. So let's go ahead and do that and make a sketch. So here's my sketch. I know that this is my y-intercept, and that is going to be y4 and x is 0 there, so that is the point 0, 4. And I have some negative slope. Can't really know what it is. I know the slope is negative 5/3, but let's generalize this here. And I need to write the equation of the new line. Well, I know a point on that line, and I know the point is 0, 4. And if I use my scale factor of 1/2, then this means that my new point becomes 0, 2. Yes. That means that I know that my y-intercept is 2. So here's my y-intercept, 2, somewhere there, okay? And since I know, right, I know that when I'm doing dilations, the lines are going to be parallel, then I also know my slope. And my slope is going to be the same as the red line. So, hey, let's make our line there. And there it is. So what's the equation of my new line? Well, I already know this. This is the easy part. I know it's y equals the same slope, negative 5/3x. And I already know my y-intercept is 2. So plus 2. And there is the equation of my new line. Okay? And this is 0, 2. But what if I had a line that passed through the origin and I knew the equation of that line? What would be the equation of its parallel line, of its dilated line? Would the line change? Would it stay the same? What am I asking really? So suppose you had this, for example, the equation of this line, y equals negative 3x. It looks something like that. What's the y-intercept here? Yeah, what is the y-intercept, right? Okay, so if you have the y-intercept, you know the slope, what would be the equation of the new line? Write that down, and that's going to be your CFU for today, okay? And you can repeat the video in case you want to find out what the CFU was, okay? So go ahead. I want to see that question answered when we get back to class.